Welcome to How to Trust a Liar. We're instrumenting AI execution with OpenTelemetry. So have you noticed this trend in tech where now that we have AI assistants to help us with coding, literally everyone and their mother thinks they're an application developer now? That's me. I'm an application developer now. After spending 5 years mostly working with DevOps, I've made an application. And what it is it's an automated engineering journal. So when you use AI-assisted coding, mine's specifically made for Claude Code, it gathers your Git diff, it gathers your commit message, it gathers all of your AI and your chat with your AI assistant, and then it automates a journal entry. But I'm going to show you what it does. We're going to do a live demo as a keynote because I like adrenaline. Let me remember. Oh, that's why, sorry. It's the, okay. Now we got this. So now first I'm going to clear it and I'll show you what I'm doing. There we are. And I'm going to reconnect to my Datadog MCP server. And here we are. And now what I want to do, let's make it bigger. Great. It says failed, but it's a liar. Already it's lying. All right. Commit the stage changes with the message KCD UK. Woo, woo, woo. Ow, ow. Boo, 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 boo. Yeah. So what it's doing is committing the stage changes, and now I can see in my journal file, I'm hoping an October 22 file is going to come up. Well, and then meanwhile here, oh, this is an important piece. So my system's designed to run in the backgrounds, but right now I have it running in the foreground so that I can get these logs for I'm in a development mode right now. And so what it's going to do is it's going to spit out a journal entry about all the work I've done in this particular commit window. Phew. Okay, so here we are, 10/22/56. That's right now. So my journal has 3 sections, a summary section. So what I've done in this commit message is I'm visiting here from Texas, y'all. Thanks for having me here at your conference. And tomorrow I get to sightsee. So I had a conversation with Claude Code about what I can do while I'm here in Edinburgh. So I have a summary section, I have a development dialogue, and that's going to choose some quotes that I had with my AI assistant. And then it's also meant to root out any technical decisions that were made. And whether you just discuss those with your assistant or it's actually looking at the code to see if you actually implemented any of those changes. So that's what it does, but I want to know more than that. It's doing fine. I want to know more than that. So what I want to do is I want to show you, I've outputted as part of my console logs, I have a trace ID. So what I'm going to do is say to Claude Code, get the trace ID from the console logs. Using this trace ID plus the correlated logs and metrics, draw me a diagram of how the system works. Search smartly and minimize token usage. Add some color to the diagram with a sprinkling of telemetry facts. What I'm especially interested in is how the chat data gets collected and prepared for the downstream generator functions. And don't embarrass me in front of my friends. So now it's good. This is going to take a little while, but it's what it's doing. So my development code is thoroughly instrumented with OpenTelemetry, which is not a normal use case for OpenTelemetry. It's going to a Datadog backend. It can go to any backend. I work at Datadog. And then it's also, it's using the Datadog MCP server to pull that back in and inform Claude Code about what's happening. For those of you who are unfamiliar with OpenTelemetry and traces, I will go over OpenTelemetry in a little bit. This is a flame graph of a trace from my journal. So this top is this is the trace, the parent trace, and then each of these little calls is a span. So I can see what's going on. I can see that the OpenAPI calls are what's taking most of the time in my trace. And then I also have correlated logs. So I can see the logs from this whole parent's trace. all 50 of them. But I also can like click in on one of these. I think the summary one's good. And I can see the logs that are specific to the summary. Whatever, I have to keep moving because I'm going over a lot here. So let's see, we don't have our you're gonna have to trust me. We don't have our diagram yet. It's a little bit slow. So therefore, I guess, aha, you almost got a joke. What's red and bad for your teeth? A brick. Okay, here we go. So this is, say, the commit story system. In terms of this trace, this is what's happening. There's initialization and validation. We're doing the chat data collection. It gets a star since I asked for a specific information here. So it's collecting Git data. It's collecting chat data. Specifically with the chat data, it's finding all of the chat data, which is stored on your local machine. It's filtering out that stuff from other projects. It's filtering out stuff from other time periods. It's also filtering out just noisy messages, tool calls, system calls, stuff you don't need. It's grouping that by session, new session. If you have two tabs open and you have two different chats going in one project, those would be two sessions. Or if you press clear, do the clear command, you get a new session. It's processing messages and filtering, and then we're doing journal generation. So first, we're doing 3 OpenAI API calls, 3 journal generators, each with their AI invocation. We have a summary and tech decisions, and then summary feeds into the dialogue. And Claude Code knows all of that. It knows save, it knows we did the journal right, we had to create a file as part of that. Claude Code knows because of telemetry data. So let's get back to the slides. There we go. I just need to remember how to navigate on my side. Yeah. Okay, so how many people here are using AI-assisted coding? Very many folks? Okay. So y'all have my back. What I'm doing here with telemetry is not normal. What the AI coding assistant usually does is it greps for keywords and then does a static code analysis of the files that it finds. And what I'm doing is brand new, experimental, untested, probably useful, who knows, stuff. And the evidence is, one of the pieces of evidence is that the Datadog MCP server that I'm showing you, it isn't even GA'd yet. It's in preview right now. But it all works on OpenTelemetry. All of my code is instrumented with OpenTelemetry, which I'll show you shortly. And I'm going to do a quick talk about what OpenTelemetry is. So at its core, OpenTelemetry is a model for how to translate system events into useful data for observability. This was really hard for me to wrap my head around at first because OpenTelemetry has a lot of different components. So first of all, also people call it OTel. If I call it OTel, I mean OpenTelemetry. It couldn't mean any of these things. OpenTelemetry is a specification, and it's so widely adopted, it's also an industry standard now. So there are hundreds and hundreds of markdown documents in the OpenTelemetry repo that are just conventions, that are just standardizations for what's happening. So an example would be if you want to collect data and you want to collect the user ID, you could express that as user.id. You could do user_ID. You could make it camel case. So OpenTelemetry has a specification for how you would express a user ID. And so literally everything you can think of that is commonly expressed, there's a specification for how it's expressed with OpenTelemetry. It also is a transport, it's OTLP, so it's a transport protocol, OpenTelemetry protocol. It is software, but it's not one piece of software because that would be too easy. It's lots of pieces of software. So we have APIs, and those are language-specific APIs that translate your code-level events into telemetry signals. There's SDKs that receives data from the APIs and correlates it with data from the rest of the system. And then there's a collector, which I'm not using as part of mine, but often if you're sending telemetry to observability backend, you want to do something with it in between, usually filter, and there's a collector for that, and that's also OpenTelemetry. So I'm using it, as I mentioned, I'm using it differently from what's normal because I've instrumented the bejesus out of everything. If you do that in production, that's very, very, very expensive and not necessarily useful. But in development, this new use case, I think it is. But how does this help me in practice? Like, is all of this OpenTelemetry business really worth it? So I can't this demo, the word demo isn't real because I can't count on Claude Code to give me a consistent experience. So what I'm going to do is a dramatic reenactment of a real debugging experience that I had with Claude Code very recently. So here we go. Claude Code, I have a problem. The dialog section of my journal, it isn't generating, it's timing out. What I want you to do is look at the Git diffs to see what changed in the code recently that could have caused this.
You're absolutely right. Use the diff first.
Wow, Claude Code, you have a voice. This is the coolest.
Looking at the code changes, I see you updated your prompts to better explain the data schema to the GenAI model. These more detailed descriptions have token overhead, and that is what's breaking your system.
You're so soothing. I really doubt that a schema explanation is the problem. That's only a couple of paragraphs of extra code. But it is something recent because I haven't noticed a journal generation failure before. Claude Code, I want you to use telemetry to examine what data is being passed into the breaking function.
What a smart approach, using telemetry over guesswork.
It's a fine approach. It's pretty normal.
Using the MCP server to query the backend, I see that the function inputs are massive. This proves our idea. The data schema descriptions are adding to the input and creating this generator timeout. Let me trim down the descriptions for you.
Oh my God, stop. It's not the data schema descriptions. Those inputs are too huge to be explained by data schema descriptions. What I want you to do is set a breakpoint so we can see the actual literal data that's being passed into the failing function.
This is brilliant. We already know the input is huge. We need to understand what is actually being passed in and validate our schema description theory.
It is not the schema description, but whatever, just run the test.
After running the test, I see the problem. And it isn't the bloated schema descriptions.
You don't say.
It is that raw chat data is being passed in, every message that passed between the developer and AI assistant during the commit window. This includes tool calls, each which could have massive 1,000-line prompts. There are 448 messages here.
We figured it out. That's great.
You are so smart and wonderful. The answer is to filter out those big tool calls. Want me to modify the dialog generator function to do that?
Well, for once I agree with you about what the actual problem is. There's too much chat data coming in and overwhelming the actual function. And I agree about the solution. Some sort of filtering needs to happen so that less data goes into the function. But before you write it here, right at this particular journal generator function, let's see if that data is being passed into all three of the journal generator functions.
You are amazing. This is the right approach. From the telemetry, I can see that the massive raw chat data is being passed into all three journal generator functions. Let me see how the system works. I'll do this my usual way by grepping for keywords and doing static code analysis. Got it! I will add the new context filtering code to the context integrator layer where other message cleanup happens.
This still doesn't feel quite right, Claude Code. It still doesn't explain why this failure only recently became a problem when I've been successfully making journal entries for months now. I also vaguely remember making this filtering before. I think I did. Let's use trace data to understand the full system flow.
You are wildly intelligent. I will follow your brilliant advice. From querying the telemetry backend, I see that the system already has filtering logic. Here's the function that already filters out tool calls and system messages, reducing 448 messages to 174 messages. But journal generators were receiving the full 448 messages, bypassing existing filtering.
Oh, you know what? A few days ago, we added functionality to better support users who run multiple Claude Code sessions at once. So specifically, we started grouping the messages by session ID before passing it to the generators. I bet that's when this broke. So verify that this is when it broke and also fix the code so the existing filtering reaches the journal generator functions.
You are absolutely right. I just verified with Git that that is indeed where the issue started. As usual, you're a genius. The fix is working with minimal code changes. Problem solved.
Not so fast, Claude Code. I do not believe you until I see real data. Use telemetry to show me that the fix is working.
The Datadog traces confirm the fix is working. Before the fix, that. After the fix, that.
That's it. Now I consider the problem solved. Great job. We did it.
You are God's gift to computing and to all of mankind.
You know there's like a term for when Cloud Code blows smoke up your ass the whole time. It's called glazing. And the and the thing that annoys me about it the most is that it costs me tokens, you know? Anyways, back to telemetry. So I have a third demo that's not really a demo. What I'm going to do is go ahead and show you what an instrumented function looks like. So here we are. I'm going to find in my utilities, I'm going to look at this journal pass function. So what this function does, let's see if we can, is, I'm just too close to my computer. Okay, sorry. Okay, so here we are. This is the function, the format date components function is what I want to look at here. And what it does is it receives a date. I just wished for it and it happened. It receives a date, and what it needs to do is make that date into something that can be the file path. So it's just breaking that date out into path components. Now, of this whole function I'm showing you, the amount of it that is the business logic. First, there's the beginning. Here's the end. There. And then the actual business logic of that function is this. So a lot of this is instrumentation, which is largely why the utilities aren't instrumented, besides the fact you don't need that data in production. So what we're doing is we're starting the trace starting the trace here. The trace is ending at the end, so the trace wraps the whole thing. And then the trace is just going to tell you the amount of time that was spent during execution in this particular function. So if you want to know more about what's happening at that time, you need to add attributes to your trace. So then that's what this set attributes is doing. And then we're also going to add, we're going to start a logger, we're going to end a logger, we're going to add some metrics, and we're going to make sure, since it's all happening within the same trace, they're all correlated with one another, which is how, when I showed you the Datadog interface earlier, you were able to see logs that were associated with one particular trace. So that's enough of that. We got the gist. And here we go. Let's talk about the benefits of trying to use development time telemetry data. So in this debugging episode that we went over alone, there are 4 ways where my coding experience benefited from the telemetry integration. The first one is that telemetry helped me disprove Claude Code's wrong assumptions. So I was able to steer Claude Code away from, when they get fixated on one thing, it's really hard to get it away from that. Another way is debugging assistance. So I was able to use telemetry and ask for, like, what did the shape of the data look like that was coming into this function? What I could have done better is I could have said, tell me what the data looked like coming into this function 3 weeks ago, and compare that with the data coming into this function today. So I'm still learning to wield the telemetry, but that would have been really cool. I would have seen right away the difference. Another benefit I saw is that having that holistic system view is really helpful. So in the debugging example without telemetry, Claude Code tried to rewrite the filtering functionality in the code twice, and it already existed. And I tried to put it in 2 different places in the code base. And here's the thing with that. If I would have said, yes, Claude Code, do your thing, it would have rewritten existing functionality, and it would have fixed my problem. So I would have moved on with my life having made a mess of my code base, and I wouldn't have been the wiser until it was a problem later, and or when I have a bloated code base with a lot of dead code in it. So in my opinion, getting Claude Code to do something that works isn't the hard thing. Getting Claude Code to do something that works in a clean way with a tidy code base that has some security, that is hard. So Another benefit is that Cloud Code can help validate your code changes. So all the time, Cloud Code is like, yes, I did it. It's done. It's perfect in every way. And it's not at all. You just like, I have to see it. I have to see it. I have to see it. Real data or it didn't happen. And then outside of the debugging example, I also have used telemetry data to help me design my system. So when I was designing how many quotes I want to feature in the development dialog section, I asked Cloud Code, like, what are the average number of user messages that get passed in here? And then that'll help me set a percentage of what I want to feature in the journal. Of course, there are some drawbacks and some unknowns, and I want to be honest about that. I'm not saying this is the end-all be-all. The big one is cost. I did all of this with no concern for cost. Datadog, like many organizations out there, are like, take all the money you want to play with AI. So I've done that. So cost, this is just me guessing now, but I think based on the scale of production telemetry, production data, what development data is going to give output seems very small. So maybe that isn't a big thing, but I don't know. And then I feel like what could be more of a cost is all the tokens it's taking with your AI assistant and the underlying models to receive and process the telemetry data. Cloud Code can make wrong assumptions about telemetry data too. It can make wrong assumptions about everything, and it will. And in the debugging story earlier, it did do this. It's like, oh, you're getting a big input to this function. It must be that schema description that you added. So it made a wrong assumption there too. Another thing, which I'm sure you were thinking when I showed you what an instrumented function looks like, is that sounds like a pain in the ass. I don't want to do that with every single function I write. I relate to that because I just did do it. What I did, there are a few ways around this. One is there's like OpenTelemetry has auto instrumentation. Your observability vendor might be using eBPF to figure out what's happening at the code level, at the kernel level. And so that could be a solution. What I did is I wrote an agent that auto instruments my telemetry when I'm finished writing functions. So I did it with Cloud Code agents. And then the last concern I have with this approach is how are you going to instrument a code base with development telemetry data and production telemetry data at the same time? And I don't know the answer to that, but it just seems like I don't know. And that's the end. In conclusion, instrumenting your code with telemetry could be a fun way to keep Cloud Code in check. Thank you very, very much. My automated engineering journal is packaged up. You can use it. It's for Cloud Code only. But if you want to give it a whirl, I would love that very much. And then you can learn more about me there. Connect with me on LinkedIn. Talk to me. I'll be around all day. Thank you so much.